So we know from college algebra class that when I have a polynomial equation, then whatever the degree of that equation is, that's how many solutions there are to that equation. So if I have a fourth degree polynomial equation, it's going to have 4 solutions. Now, our favorite way to solve this equation is to factor it if we're able to do so. And so we can factor it here. Okay, we could keep going with the x squared minus 1. I guess I might as well do that. And x squared plus 1 doesn't factor. Then the zero factor property says that if we set each factor to 0 and solve for x, then we'll find our solutions. So of course here x is -1, and here x is +1. And then our other 2 solutions are going to be complex numbers. And in all fairness, all 4 of these are complex solutions. Any real number is also a complex number. Okay, here's 1, 2, 3, and 4. Okay. We can talk about a root of a complex number if we want to let u be some complex number a plus bi. Okay. Then if I want to talk about the nth root of that, we say u is the nth root of z, since u to the n power is equal to z. It's much the same as we define it with real numbers. Okay. So to find a formula for this, I thought about writing it all down, and you should read in your book. The definition is there, and I think the author explains it very well, so there's not a reason for me to write it down and take several minutes of the video. But if n is a positive integer, okay, positive meaning not equal to, n is a positive integer, and I'm looking at the complex number z in its trigonometric form. I can squish it in there. Okay. Then z has n distinct roots. So if I want to talk about the square root of z, I can. If I want to talk about the 57th root of z, I can. If I want to talk about the 5th root of z, I can. So I'm going to choose n, and n is the root I'm after. Okay. Then one of my roots is going to be the nth root of r, and we know what that's defined to be. I mean, that's a real number, nth root, times cosine of theta plus 2 pi k all over n plus I times the same thing, and I didn't leave myself enough room. I times sine of this. The 2 pi k has to do with the period of the sine and the cosine, and that's for k from 0 to n minus 1. So if I'm after the 10th root, okay, then if I let k go from 0 to 9 and plug it into this formula, there's my 10 roots. If I just want the square root of z, then k would be 0, k would be 1. That would give me my 2 roots. Okay, I'm going to pause and copy this to a different page, and then we're going to click over and do an example. So let's be boring and do the number we started with on this video. Let's let z be the number 1, which can be thought of as 1 plus 0i. Trigonometric form of this number, also boring. 1 squared plus 0 squared is 1, and the square root of 1 is 1. And the tangent of theta is 0 over 1, which is 0. 1 is straight right, and so I know that my theta is 0. I'm in that, I'm going to say first quadrant. We're actually on the axis there. So my real number No. So my trigonometric form of my complex number z is going to be 1 times cosine 0 plus I sine 0. Maybe I want to find the fourth roots of z. Okay. So there's going to be 4 of them. We get to use this formula 4 times, finding z sub 0, replacing k with 0. Okay, because I want the fourth root, 4 is my n. We know the r, we know the theta, so we get to do this, we get to use this formula 4 times. Okay, I want the fourth root of r each time. Cosine of theta was 0, plus 2 pi k. If k is 0, then that would be 0 over 4, plus I sine of, I'm going to go straight to 0 here because 0 plus 0 over 4 is 0. So the cosine of 0, start at the beginning. Fourth root of 1 is 1. Cosine of 0 is 1. Sine of 0 is 0. One of my fourth roots of 1 is positive 1. My next one, and your author draws a nice picture hopping around the circle on this to help you visualize it if you need to. So again, your author does a good job and draws good pictures, much better than I could. So go ahead and look at those. If k is 1, and I'm adding 2 pi, pi sine 2 pi over 4 is pi over 2. And I'm going to write it literal here in this step and then just simplify it, not recopy it twice. The cosine of pi over 2 is equal to 0, and the sine of pi over 2 is equal to 1, so I get I. Go ahead and pause the video and find the other 2 roots for me, substituting a value of k equals 2, and then going back and doing k equals 3. So 4 pi over 4 is equal to pi, 6 pi over 4 is 3 pi over 2. The cosine of pi is negative 1. The cosine of 3 pi over 2 is 0. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And so here are our 4 fourth roots of 1. Okay, notice those are the same 4 solutions that we got back here. Those are our 4 roots, our 4 roots of positive 1. Okay, well, let's do one more. We'll start it on the next page. Yeah, we'll do one more. Let's look at the number 1 minus the square root of 3 times I, and let's just go with finding the square roots. That way we only have to find 2 of them. Okay, so from the formula on the other page, copy and paste it over here. Pause the video. First we have to find the r and the theta and put it in trigonometric form. Okay, then we should be able to substitute in the formula and find those 2 roots. Go ahead and pause the video and see how far you can get. Just a quick checkpoint, you should find out that r is 2. Your theta is 5 pi over 3 because if I go right 1 and down square root of 3, I'm in the 4th quadrant, so with a pi over 3 reference angle. Okay, now you're ready to find your roots. Okay, so here is what I've gotten for my 2 square roots of 1 minus the square root of 3 times I. Okay, I'm going to tell you though that I checked these and neither of these are right. So I've paused the video now and I've done it 2 or 3 different times and I'm not seeing where my mistake is. So I would like very much if you guys, when you watch this, could sit down and play with it and tell me where I went wrong. Because if these guys are the square roots of this number, then when I square them, I should get that number. And if I square this one, I think I get negative 1 minus square root of 3i, so that's not right. And when I squared this one, I got a negative 1 here and a plus square root of 3 there, and I even Googled that one. What is this squared? And so I know that that part of my arithmetic's not wrong. So help me fix this. me an email or feel free to put something out there. I don't know if you guys have a good way that you could talk to everybody, but send me an email and let me know if there's a place you can find to put a comment. Do that, and we'll figure out what the problem is. And if I can figure out a way to fix it after I've taken a break and walked away, then I'll post that that correction. Thank you.